what I'm going to do today is kind of talk about what else we could notice about these to shorten our process of graphing. Because plugging in all of those points gets time consuming. And there is actually a shortcut. If we compare everything to the most simplistic quadratic equation, the most basic quadratic equation is just y equals x squared. We call that the parent function. It's what the basic graph starts out looking like. And then we can do transformations. Transformations are a change to the size or position of a figure. So what I want to do now, we're going to look at the next few graphs. You notice there is already something graphed on these graphs. That is y equals x squared, the most simplistic quadratic equation. 0 squared is 0, so 0, 0 is 0. 1 squared is 1, so 1, 1 is 0. 2 squared is 4, so 2, 4 is 0. Negative 1 squared is 1, negative 2 squared is 4. That's where this one comes from. I have already graphed that basic one for you. What we're going to do is we're going to graph the other one and see if we can figure out how the basic one was changed to get to the new one. So if I look at problem 7, right, if I were doing this yesterday, we would have done the vertex. So my vertex, we set the inside equal to 0, so that gives me x equals negative 2. So that's the x value of the vertex. The y, what's added or subtracted on the end? 0. All right, and then we plug in points smaller and larger. So everybody grab a calculator. We are getting much better at plugging these in. All right, U3, plug in negative 4. You guys plug in negative 3. You guys plug in negative 1, and you 3 plug in 0. So, my negative 4 people, what did you get for your answer? My negative 3 people, what did you get? My negative 1 people, and 0. Let's graph this. Remember, x is left and right. So we go left 4 and up 4. Left 3, up 1. Left 2, didn't move up or down. Negative 1, 1, and 0, 4. That's my final graph. Can you guys tell me, how is that different from the original? What did I do to that basic x squared graph to get here? Okay. So my transformation this time was left 2. I got my new graph by moving the basic one, x squared, left 2. Notice, that's because we added 2 on the inside. Okay. Let's try the next one. First, let's get our vertex. So my vertex, x, there's nothing with it, so it's just 0. What's my y? 5. Smaller than 0, bigger than 0. All right, far side, you guys do negative 2, negative 1, 1, you 3 have 2. Plug them into the equation. Let's see what we get. right, -2, what'd you get? -1. Make sure you put your -1 in parentheses. You should get 6. 1, what'd you get? And 2? So let's graph -2, 9. -1, 6. 0, 1, 2, 3, 4, 1, 6, and 2, 9. So, how did this graph move? Up 5. So if we add something on the end, we know on the end it changes your vertex, changes the y value, so it moves it up or down. On the inside, it's changing the x of the vertex. That's what moves it to the left. Okay, let's look at, let's go to this one. Number 10 has a lot going on. If we want to find our vertex, we take the inside equal to 0, so we get 4. What will the +1 do to my graph? Where's my y value going to be? 1. Alright, so smaller and larger. Right. 2. Noah, Kale, Aiden, you guys do 2. You guys do 3, 5, and 6. Plug them in, let's see what we can get. Don't forget the negative in front of your parentheses. Alright, 2. What did you get? 3. What did you get? 5. 6. So +2, -3, +3, 0, 4, 1, 5, 0, and 6, -3. This one did a lot. So let's think about our vertex. It started at 0, 0. To move here, it had to move to the right 4. It had to move up 1. Okay, look at that. We subtracted 4, that moved it to the right 4. We added 1, it moved it up 1. What else happened to my graph? It flipped. That negative in front caused my graph to flip upside down. Okay, so we're kind of getting a feel for our transformations. If it's on the inside with the x, it'll move it left or right. If you are adding, it's going to the left. If you're subtracting, it moves it to the right. The number on the end will move it up and down. Adding moves it up, subtracting moves it down. A negative flips it upside down, which we already knew. If it had a negative a, it had to be an upside down parabola. Let's look at one more. Number 11. I want you guys to take a few minutes, get your vertex, and draw your graph for me. The x value of the vertex comes from what's added or subtracted with my x. Is there anything there?
No.
No. So when you set that equal to 0, you just get 0. The -7 will make it -7. So then take x's on both sides. 2. You get 5. -1 gave you
-4.
1, 2. Okay, so -2. 4. -1. 0. -7. 1, -4. And 2, 5. All right. So I can tell vertex moved how? Okay, it went down 7. What else happened to this graph?
It got longer.
Yeah, it got skinnier and taller, right? That's because of the 3 in front.
I don't know why.
You didn't take them. So the -7 made it go down 7. Multiplying by 3 made our graph get skinny. Because I told you, it can change the position, which is like the left, right, up, and down, or it can change the size. So we can call that a stretch. It's like if you take a rubber band and you stretch it. The higher you stretch it, the skinnier it gets. Okay, so that's what happened to our graph. We took it times 3, so it got taller and skinnier when we did that. So those are all the different transformations. If we have something in vertex form, like we talked about yesterday, the H is the horizontal shift. Make sure everybody needs to write this stuff down. We are going to reference it tomorrow as well. So you need to have these things, these blanks filled in. When you are adding, it will go left. When you subtract, it goes right. We saw that in our graphs. Adding to the x goes to the left. Subtracting goes to the right. The k, the number on the end, that changes the y value of the vertex. So that's our vertical. It's the up and down. Adding goes up. Subtracting goes down. All right. If the A is negative, if you have negative in front, it is flipped over the x-axis. It becomes an upside down graph. If you're multiplying by something bigger than 1, it's a vertical stretch. Okay, it is, if I take it times 3, it's like taking the height of something times 3. If I have my original parabola and I shift it up 3, it's getting skinnier. But if it's smaller than 1, as you come down, it's going to get shorter and fatter. So that is called a shrink. It's like the height. Do you want 3 times the height, or do you want 1/3 of the height? So bigger than 1 stretches it, smaller than 1 will shrink it. Sometimes that is also called a compression. I'm okay with either term, but just know you guys are going to take the EOC, so you might see either word on there. So compression just means you're taking it and you're squeezing it down, so it's going to get short and fat. Stretching, it'll be tall and skinny. All right, we aren't going to draw any more graphs today. We're just going to talk about this. So everyone needs to have this written down. You're going to reference it as we look at these bottom ones. So number 13. If I want to move something, we're going to write an equation. 2 units to the right. Okay, if it's left and right, it has to be attached to the x, because you're moving the x value of your vertex, left or right. So that means it's on the inside. I always tell people, if you add to x, go left. If you add to the y, it will go high. So just a little trick to help you remember. So if I add to the x, it goes to the left. If I want to go to the right, that means I have to subtract from my x. I want to move it 2, so it's x minus 2, and it is a parabola, so we have to have that squared. So to move it to the right, we have to do x minus 2. Okay, up. If you add to the y, you go higher. So this is on the outside, just tacked onto the end. Up is plus. So the x squared plus 5. All right, number 15. We have a couple things. Add 3 units to the left. Add to the x, it'll go to the left. So if I want to go to the left, I have to add to my x the 3. Don't forget the square. The square is always here because it's telling us we have a parabola. And we go 4 units down. So what does that mean I need on the end? Number 16, translated 7 units to the right. How do I go to the right? So x minus 7 squared. 4 units up. Plus 4. All right, number 17. Reflect. Reflect just means flip over the x-axis. So what makes it flip?
The a is negative.
A negative. Okay, and then I'm going to go down. So if I'm not moving left or right, it's just regular x squared. We have the negative for the flipping. And then 3 units down, that means we should subtract 3. Number 18. Reflect over the x. What makes it reflect? A negative. We're going to go to the right. If it's left or right, we have to have something in with the x. If adding to the x goes to the left, what would make it go to the right?
Subtracting.
Okay, we want to move 5 to the right, so we subtract 5. 2 units down. Down is subtract 2. All right, stretching and compressing is just multiplying by a number. Vertically compressed by a factor of 1/3. That just tells me we multiply the x by 1/3. And then 8 units up and down, you're just adding that number on the end, so we just have plus 8. Number 20, vertically stretched by 2. That means we have to take it times 2. Reflect over the x. So what do we have to have?
Negative.
A negative. So we'll do a negative 2. Translated 4 to the left. Left and right is inside with the x. Add to x, you go to the left. So x plus 4 squared. So negative 2, x plus